All right, guys, this is the video for 7.4 video or 7.4 notes. Sorry, I'm doing these at home, so the video is going to look a little different. To kind of do a makeshift kind of thing here that's not really working for me very well with that shadow right there, but I'm trying. All right, I guess that'll have to do right there. Okay, so we're talking about applying the Pythagorean Theorem. And the first thing we want to talk about is how to apply it to a 3D shape. So the first thing we want to talk about is, so this is a 3D shape right here. This line that we're trying to find, because it says find the length of AB, it cuts through the center of a box. And I don't really have it. My box, I have boxes at school that I can show you. It looks better, but so it's going to cut through. So it's going to come from like this tip here up to here. So it's going to cut through the center of that open spot of the box. Okay, and so that's what we're kind of looking at. And so let's see, this is kind of crooked. There we go. All right, so in order to do that, we kind of have to take this in two steps. So the first thing we're going to do is we're going to find the diagonal of the base, the diagonal distance of the base. So here's the base right here. Okay, and we want to find this diagonal right here. Okay, so it's kind of like right now we're dealing with just this 2D shape, right? Just the very bottom. So it's like the piece, you know, it's like a flat piece on the ground that's sitting on the ground. And we want to find the diagonal from the top or from the bottom left-hand corner up to the top right-hand corner. So basically what we've got is this triangle that looks like, triangle that looks like this, okay? We're trying to find this. And we can see right here that the length of this is 24 inches. And the width of this is 8 inches. Okay, so we're just going to do Pythagorean theorem to find that C right there. So 24 squared plus 8 squared equals C squared. Oh, and I didn't get out my calculator. See, that's what happens when I do this at home. I'm not prepared. So I have an old, bigger calculator, but it works the same way. So I can do this all in one step in my calculator. So I'm just going to open up the square root sign. And I'm going to do 24 squared plus 8 squared underneath it. So 24 squared plus 8 squared. I'm just going to hit enter. And on my this calculator right here, it automatically gives you decimals. On your guys' calculator, remember, if it doesn't, you can just hit that button that's down here, the little 2 arrows, and it will convert it to a decimal. So rounded to tenths, this would be 29.3. So this is 25.3 inches. Okay, so this part right here is 25.3. Now what we're going to do is we're going to take that diagonal distance that we just found, this one right here, and it's now going to become one leg of our triangle, this right triangle. And the other, and the height will become the other leg. So this right here is going to become, this is going to become the other leg. And now we can find this distance. Okay, so I know that this distance right here is 25.3 because I just found it. And I can tell the height is 15 by looking right here. So this is 15 inches. Okay, so then what we're going to do is we're going to label the sides of the triangle A, B, and C. Okay, so this one could be A or B, it doesn't matter. And this one can be the opposite, right? A or B. And again, we're trying to find C again. Okay, so then we're going to plug it into the Pythagorean theorem and then solve it. Okay, so we're going to do this one more time. I'm just going to kind of take this, because this is kind of like standing up inside, it's like that sliver that's kind of just inside the box. I'm going to take it and just kind of put it right here as a 2D shape. So I've got it like this now. This diagonal here now becomes the leg here. So this is 25.3. And the height is 15, and I'm trying to find C. Okay, so 25.3 squared plus 15 squared equals C squared. So again, I'm just going to use my calculator. 25.3 squared plus 15 squared, hit enter, and rounded to tenths place, it's 29.4. So that new one is 29.4 inches. So this length that we just found now, that line AB, so this is AB, line AB is another name for C, is equal to 29.4 inches. Okay, now there's a much easier way to do this, but this just kind of shows you how to do it. So with a highlighter or something, put a little kind of cloud looking thing here so that you can find it easily when you're on the test and trying to use this. But hopefully what you can see here is I labeled them with height, length, and width just for a specific reason. So on this one right here, remember what I did was I took the square root of them, remember, in my calculator, and just put this whole thing in my calculator. Well, if you look, this 24 squared is actually the length, and this 8 squared is actually the width. So what we did was, to find that length of that line, we put it in the square root, and we took the length and we squared it, and we added it to the width and we squared it. Then once we found that answer right here, we put it down into this one. And right here, what I did was I took the square root of both sides, right, after squaring them. And so this answer is right here squared. And then what I did was I took the height and I squared it. So I can do this all in one shot by just doing length squared plus width squared plus height squared, and then take the square root of it. All in one shot, watch. Okay, so the length squared is 24. The width is 8, square it. The height is 15, square it. Hit enter, and I get 29.41. It's a little different, it's not quite exact, but you can see that it's close enough for rounding purposes, right? 29.41, 29.41. Okay, so that's just an easier way to do it, but it's just, we kind of walked you through this way so that you could understand where it came from. Okay, so let's practice it a little. Let's do this one right here. So we want to find the length of AB. So we're trying to find this diagonal length that cuts through the box, just like we did up here. And we're just going to use the shortcut way. So that length of AB, and you can write that like this, line AB is equal to the square root of the length squared plus the width squared plus the height squared. Okay, and again, you can just put this in your calculator. You don't have to write it all out. So square root sign, 13 squared plus 6 squared plus 13 squared, enter. And rounding to tens place, I get 19.3. And this is in inches, so 19.3 inches. Okay. All right, let's do another one. So find the length of AB. So again, we're trying to find that diagonal length again that cuts through the open box. Okay. Now this one doesn't have the lengths around the box, but it does have them listed right here. So it says AC is 12 centimeters. So this is 12 centimeters, AC. CD is 5 centimeters. And BD is 2 centimeters. Okay. So we want to find the length of AB again. So length, or line AB, is equal to the square root of my length. And again, you know what? You guys don't have to put these in this particular order. You could do width first, then height, then length. We're adding them, so the order doesn't matter. So you could really just go around the box and pick all the numbers. It doesn't really matter, but I'm just going to follow this. So the length is 12, and the width is 5, and the height is 2. Okay, so I'll just put that in my calculator. I don't know if you can here, I'll put it over here. So 12 squared plus 5 squared plus 2 squared, enter. Rounded to tenths, it'd be 13.2. So the line AB is equal to 13.2 centimeters. Okay, so that is basically how to use Pythagorean theorem with a 3D shape, specifically a cube. Or a box. Now we're going to just kind of put the Pythagorean theorem in play using it in all different ways. All right, so first one up. Let's talk about this one right here. It says, Craig is moving a circular table into his house. His front door is the shape of a rectangle with a width of 36 inches and a height of 80 inches. If the table has a diameter of 86 inches, can he fit it through the front door? So we want to draw some pictures here. So here's my door. little doorknob right there. The width of my door is 36 inches and the height of my door is 80 inches. Okay, then I've got this table with a diameter of 86 inches. A diameter, remember, measures from one side to the other. Radius is from the middle out. All right, so what do we know? Well, we know that we can't, I'm not going to write this all out, but we know that we can't fit it, if I was to just pick it up and take it through, we can't fit it that way because this is 36 and this is 86, so we're off 50 inches. I also know I can't stand it on its side and push it straight in because this door is only 80 inches and this table is 86. So, but we want to do is we want to see if we could kind of turn it at an angle and slide it through. So like this, can I do that? Well, if you look, you can see that this creates a right triangle. And if this is a right triangle, then I can use Pythagorean theorem to find this diagonal length. Okay, so, and if this diagonal length, if the diagonal, we can write this in here, is greater than 86 inches, the table will fit. Okay, so let's see. Let's work it out. So over here, we'll work it out. So the C, remember this is C. Oops, geez, that's a bad C. There's something under there. Equals the square, yeah, well, C equals, we could write it this way, the square root of 80 squared plus 36 squared. Okay, this is the same as writing this. Sorry, I was thinking before I was writing before I was, well, anyway, these are exactly the same, okay? So if I take the square root of C squared, I get C. And if I take the square root of this, I get that. Same thing. Sorry, I didn't mean to write it like that, though. All right, let's put it in our calculator. 80 squared plus 36 squared equals, so rounding to tens place, that would be 87.7. So C is equal to 87.7 inches, which means that it should fit. Because we said if the diagonal is greater than 86, which it is, that table will fit. Okay. All right, next page. All right, so the next one, it says the state of Colorado is basically the shape of a rectangle. The greatest distance from east to west is 377 miles. Its greatest distance from north to south is 257 miles. Find the approximate distance between the opposite corners of the state. Let me get some real light in here. Maybe I won't have as much shadow. Okay, so let's do this. Let's draw it out. So it said it's basically a rectangle, so let's just draw a rectangle. Okay, then it says its greatest distance from east to west. Well, never eat soggy waffles. So east to west runs horizontal, so that means that the horizontal measurement is 377. And then its greatest distance from north to south, which is its vertical distance, is 257. Okay, so now what it does is it wants us to find the approximate distance between the opposite corners of the state. So from here to here, or you could even do it this way, it doesn't matter. And then it wants us to round to the nearest whole mile. Okay, so here's my right angle. This measurement is the same as this one down here, so we could just rewrite it if we need to. So this is C. So what we get here is 257 squared plus 377 squared equals C squared. We're going to take the square root of both of them, right? And that's how we're going to put it in our calculator so that we can get C. So 257 squared plus 377 squared equals 456. Rounded to the nearest whole mile would be 456. So C would equals 456 miles. Okay. All right, next. You leave your campsite and you go north for 2 miles. Then you turn and head west for 5 miles. Then you turn and hike north another 3 miles. You finally turn and go west another 7 miles. How far are you from the campsite? So we're going to do a whole bunch of north and west. So I'm going to start down here at the southeast corner. Okay, so here's my tent. Okay, so the first thing I do is I leave and I go north. Well, north is up. So I go up 2 miles. Then I turn west, which is left, and head 5 miles. Then again, I turn and go north another 3 miles. Then finally, I turn west again and go 7 miles. Wants to know how far away I am from the campsite. So basically, it wants this distance here. From here all the way back. And that is a really bad diagonal line because I drew my other lines bad. Sorry. But it wants this whole length here. So there are 2 different ways you can do this. You can break this up into 2 different triangles, right? I could find this length here by using the 7 and the 3. Then I could find this length here by using the 5 and the 2, and then I could add those together, which is perfectly fine. You can do that. Or you can make it one big triangle and just find the length all together. So like this, okay? Which means this is 7 plus 5, so this is actually 12. And then this one is 2 plus 3, which would make it 5. So then I can use it to find this whole diagonal here. So that's the way I'm going to do it. So what I'm going to do is 12 squared plus 5 squared equals c squared. Put it in my calculator. 12, oh geez, that's not right. 12 squared plus 5 squared. Enter. And it comes out to be perfectly 13. So C is 13 miles. All right, 2 more. So a 20-foot ladder is leaning against a house. The bottom of the ladder, oh, let's just draw that. So here's this 20-foot ladder that's leaning against a house, okay? This is 20 feet. The bottom of the ladder is 5 feet from the base of the wall. Oh, I drew this really bad, but this should only be 5 feet here. It's not very proportional, is it? About how high does the top of the ladder reach? So it wants to know this distance here. Round to the nearest tenth. Okay, so on this one, this is my right angle right here, and I'm using it to find, obviously not C because I have C, so it's a leg, so you could just make this one A and this one B. This is from 7.1 notes in case you're wondering. Okay, so 7.1 notes, so to find a missing leg we subtract. So we've got A squared plus B squared equals C squared. Now, if I want to do this in my calculator, I want to show you guys something. Up here, remember when we're doing them in our calculator, we would add them together. But remember when we're finding a missing leg, we need to subtract them. The one thing you got to make sure you do is you got to make sure you always do when you're doing the subtraction ones, and you could just write this over here. When you're trying to find a leg, you always want to do C squared minus the other leg squared. And I didn't put A or B because you can always change it, but you always want to put C squared first because it's the bigger one. Because you can't take the square root of a negative number. Watch, I'll show you. So if I did 5 squared minus 20 squared, I'm going to get an error. Watch. See, there's an error. Because you can't take the square root of a negative number. So you've always got to subtract the bigger number first. So I want to do 20 squared minus 5 squared, like that. Okay. Hit enter, and it rounded to tenths place because that's what it told us to round to, is 19.4. So B in this case is 19.4, and we're talking feet. Okay. So that's 19.4 feet from the ground to the top of the ladder. All right, last one. So 2 bicyclists left lagoon at the same time. So let's draw lagoon. Put it right here. Here's lagoon. Okay. One traveled east 9 miles. Well, remember, never eat soggy waffles. East is to the right. So he traveled east 9 miles. Okay. And one traveled south. So south is down. When the bicyclists got home, they were 15 miles apart. So that means if this is home here and this is home here, this distance to this distance, this place to this place, this distance is 15 miles. Okay, so it wants to know how many miles south did the bicyclist travel? Well, hopefully you can see that we are not looking for C. We've got C here. So we're looking for A or B. So we'll just give this one B and this one A. Plug it in. So A squared plus B squared equals c squared. Okay, now remember this is the same as this up here. Okay, so I'm going to be subtracting because I'm not trying to find c. So what I'm going to do here, and I'm going to make sure I do my c squared first. So 15 squared minus 9 squared, enter, and it's just 12. So a equals 12, and we're talking miles, I believe. Yeah, miles again. Okay, that's it. That's all. If you have any questions, let me know. Thanks, guys.